Kia ora Year 12 and Year 11. I'm going to do a couple of questions from the textbook on partial fractions. So these are not, I'm not going to teach this as slowly as I do in the main partial fractions videos that I've made. This is just if you need a quick refresher. So here's the first one. We're asked in the question to write this expression as a sum of partial fractions. So the first thing we always check is we look at the order of the top line. In other words, we look at the highest power in here, and it's a 2, right? So the order there is 2, and the order of the denominator, we want to be higher than that. And that's good because we've got a cubic down here, so that's 3. So that means we can proceed to split that up into partial fractions. But before we do that, what we need to do is to factorize this thing here, if we can. So we're going to rewrite it as follows. 5x squared plus 13x plus 10 over 2x plus 3, and we've got a difference of 2 squares, so x plus 2 times x minus 2. So what we'd like to do now is to find a way to split that up as follows. So we start by writing out the single fraction, and we're going to break this one into 3 very simple fractions. So one of them is going to have something over 2x plus 3, then something over x plus 2, and then something over x minus 2. And my numerator in each case is just going to be a number. Why is that going to work? Well, if you look at what's going to happen when we cross multiply, we're going to have a here times this times this. So that's going to generate a quadratic. Similarly, for the next bit, we're going to have b times this bit, and that's going to generate another quadratic. And c is going to be cross multiplied through by this bit and this bit, generating another quadratic. Now, when you're doing this case, this is the simplest case, you're probably thinking, why is she saying that? Well, it's because later on, when you've learnt some different pattern types, I want you to have some intuition for where they come from. So we always have a quick look at the form first. Right, so we want to find the a, b, and c that make this true for any value of x. So what can we do? Well, we get 5x squared plus 13x plus 10 is identically equal to a times x plus 2, x minus 2, right, so never expand these out, just leave them like this, you'll see why, times 2x plus 3, what have we got left, x minus 2, and lastly plus c times this bit and this bit. Now, what I'm going to do here is use a mixture of the two methods we've seen. I almost always start by doing substitution, and the two values that I'm going to substitute are going to be x is negative 2, and then x is 2, because I'm going to generate a bunch of zeros that way. But when I get to the last one, to make this 0, I'd have to have x is negative 3 over 2. Now, the chances that I muck that up are quite high. So instead, what we're going to do is figure out 2 of the coefficients using substitution, and then we're going to do the last one by matching up coefficients, and I'm going to match up on the constant. So you might want to pause the video and just work it through now and see if you get the whole way there. So I'm going to start by saying let x equals negative 2. Substituting, I get 5 times 4 minus 26 plus 10. Please don't skip steps and try and do that in your head, you will probably go wrong. Equals a times 0 plus b times negative 4 plus 3 times negative 2 minus 2 plus c times 0. Right, what have we got over here? Well, we've got 20 plus 10 is 30 minus 26 gives me 4, so 4 is equal to b times negative 1 times negative 4, generating 4 equals 4b, b is equal to 1. Now, bear in mind that partial fractions problems in the Cambridge exam are usually the first part of a binomial expansion question. So you really don't want to muck this part up. And if you're getting a number here that's not a nice number, it's worth going right back and checking that you haven't stuffed up some of your substitution. It's very easy to do. Right, so we've got b figured out. Next we're going to substitute in x equals 2. What will that give me? Well, I get 5 times 2 squared, so 5 times 4, plus 13 times 2 is 26, plus 10 is equal to, well, let's see, we're going to have 0 here and 0 here. So 0 plus 0 plus c times 4 plus 3 times 2 plus 2. Right, so that's 2x plus 3 in there. And that gives me 56 is equal to 7 times 4 is 28, so 28c. Giving me a nice simple number, c is equal to 2. So what can I say now? Well, I'm not going to keep going with substitution. So we can say that 5x squared plus 13x plus 10 is equal to a times this. Now we know b, it's 1, so it's 1 times 2x plus 3 times x minus 2 plus 2 for c times 2x plus 3 times x plus 2. Right, so we don't have to expand all of that out. We're just going to match the constant. So matching the constants, and I'd like you to write some kind of thing like that down, we get 10 is equal to negative 4a, right, so there's my constant here, times a, minus 6 coming from here, plus 2 times 3 times 2, which is 12. Right, so we get 10 equals negative 4a plus 6. 4 equals negative 4a, and a is equal to negative 1. So we're finished. But remember that we need to write that back to finish it off. Okay, so what do we have? 5x squared plus 13x plus 10 over this, 2x plus 3. Put it back into the original form, x squared minus 4 is equal to negative 1 over 2x plus 3 plus 1 over x plus 2 plus 2 over x minus 2. So there you go, that part's done. Now, if you were asked to do a binomial expansion now, say a quadratic, what you'd do is you'd go and do this one, and this one separately, and then you'd add them all up together. Much, much easier than attempting to deal with this horrible fraction over here. Thanks for watching. I'll pick out a couple of other questions from 7D and 7E later on this weekend.